Alright, time for another draftphysics.com, debatephysics.com also, but not much to debate. I was thinking about what to do about these redundant arguments, because I have said stuff on this coupled oscillator a few times, and it's just ignored. And you're just saying, well, what's the point? Okay. And for other viewers who aren't that interested in this minutia about these experiments, and the ones who are paying attention, yes, they're like, well, you already said that 4 times, Gary. You don't need to say it again. I already heard you. I listened. So maybe I'll just title all these videos that are responses to junk experiments, response to junk experiment. Okay, so that'll just make it so much better, I think, for somebody who just doesn't want to go through this minutia over and over again, where I explain it's a time-dependent force and all that. So anyway, so the Dispar guy's working on the coupled oscillator, and he just keeps doing. I mean, I did say it 3 times now, 3 exactly, at least. And so now I'm going to say it a 4th time. And, he just, for whatever reason, he just ignores these pieces of advice, the ones that I think are really important. He pays attention to the things that aren't so important, and he misses entirely the ones that are important. So here's him doing the experiment. Look what he's doing again. He's pulling the weight to the outside. Now, first thing you would figure out, I think, is that, well, I'm going to be doing this experiment a lot of times. I might as well find a standard way of putting the energy in. Then I'll always have the same energy in. I'll always have numbers that are always quite relevant because they're all connected to each other. So each time I do the experiment, the numbers will be very consistent. It seems like something you would figure out how to do. But anyway, he's pulling the weight to the outside, which pulls this weight out, which means your momentum isn't just in this side, it's in this side also. So you split the momentum between both objects. So you don't even know what the total momentum is that you put into the system. So really not a good idea. He just keeps doing it. Here, you can see it, right? I mean, I shouldn't have to emphasize it, but he's pushing it out this way instead of pulling it in this way. If he pulls it in this way, this weight will not move. It'll be completely left alone. So you won't be storing energy anywhere else. So if he pulls it inside and lets it go, then he knows exactly how much momentum he started with in the experiment. This first pass through the gate will tell him exactly how much momentum he gave the system. And then he can see if he can make more momentum somewhere. That's simple. So it makes the experiment, it gives the experiment a dual purpose in the sense that, well, you don't need to go through the whole coupled oscillator thing, because all you're really looking for is any place where you have more momentum than that initial momentum. Why that's going all over the place. Anyway, yeah, so we can get rid of that and I'll do the drawing part. So, yeah, so I'll just illustrate what I just said, okay? And I've already said it. So he's got 2 pendulums. One is twice the mass. So let's understand that any movement by this object, okay, is twice the momentum of the same movement in this object. So if the 2 objects move the same amount, this is twice the energy, the momentum, twice the mv. So if this one moves twice this distance, it'd be the same as this one moving just a little bit. So the 2 mass clearly stores a lot more energy in the same amount of motion. Okay, so that should be understandable. And clearly when these 2 things are tied together, when you pull this out this way, you pull on this string, which means this object is lifted up, okay, and over. So it's not only given it's risen in gravity, it's also moved sideways. So, it's going to have stored some momentum. So, and if you move it this way, okay, to drop it, then obviously this doesn't move and you haven't stored any energy. So if you do it the right way, okay, from the inside out, then you can get a number here. Let's say the number is 100. And let's say you just create a little wooden block or something to put the weight on and just move it back, and you end up with a consistent number each time. Each time you do it, you can get the same amount of energy in. get the same speed here, okay, then that'll give you the opportunity not to worry about timing gate being on one side or the other, because you can basically do the same experiment with the gate on this one and then with the gate exclusively on this one, and you can just compare, put those two videos side by side with the timing gates and see exactly what is where and which way it's moving. There will be a difference. When something's moving this way through the gate, you're going to get a different number than when it's moving this way. This way will be the clean way, where it hasn't been jerked. This way will be the unclean way, where it has been jerked. It's been given an acceleration. So, that also makes a difference. So all you're really looking for is if you put the same energy in each time, you have this 100 momentum, and you should do it with both things, right? Do the experiment moving the 2 mass and starting with the 2 mass with the momentum. And then all you can say is look, I have a number from this initial action, and all I want to do is see if I ever get that number over here more than that number. So if I can get 120 or 30 momentums over here, well, then you've proven the fact that you can make free momentum. But pretty simply, all you need to do is get this number measured accurately and have a certainty that all the energy is represented by this number, and then you're just saying, let me see if I can find that number again. What he's doing is he's putting a certain amount in and pretending he doesn't have energy moving in some other part of the system right from the beginning. That's the problem with doing this, pulling this one back. So you can't do this. This is a mistake. You have to do this to start, and then you'll know exactly how much momentum you started with, and you can see, just watch it. See what happens when the energy moves from this side to this side back again. See if it's 90 or see if it's 80. And then the third try, if the third try is like 70, right? Say the second try ends up being 80, and the third try is 70, and the next time it's 60. So it's losing 10. Well, how come it lost 20 the first time? Right? You'd have to say, gee, what happened the first time? And the point would be is that, the first time it's stored 10 somewhere. Somewhere there's still a missing 10. That kind of thing. So at least it'll tell you something. But all you really need to do is start with a known momentum and then show that you can get more momentum in this side. Not that complicated, really. All right. So that's where we are. So he's done a whole bunch more experiments. It's a lot of work, blah, blah, blah. Sorry about that. But, you're not doing it the way you need to do it to glean real information out of the experiment. You're still just vaguely saying, well, it's not moving much. Well, how much it has to move to be storing 20 or 30% of the momentum. Do you know how much it moves to have 30% of the momentum? I don't think you know that. I don't think you know it by sight anyway. So you're just sort of saying seems like rather than I'm going to prove like, and big difference and all that crap. So, so he did 3 different trials with different circumstances. One circumstance, the 2 mass is still moving when this one's swinging. This one's still moving a little bit, the 2 mass, and the other one, the 1 mass is still moving a little bit, and the other one, both of them are moving a little bit. So, not great. And really, like I said, all you really need to do is be sure of the energy you start with, and then you can see if you can find more energy in the system somewhere. And so that would just simplify the experiment. All right. So I think that's probably enough. I'll pause, but it's probably enough. All right. Just glancing at the comments, there's nothing meaningful in here. Dispar concedes DS pointed out in the previous test that the 2 mass didn't transfer all its mass to the 1 mass. I just pointing out that the 2 mass, a little bit of wobble in the 2 mass is twice as much energy as a little bit of wobble in the 1 mass. So you have to understand that the 2 mass stores a lot more energy in any motion it has. Okay, that's all I said. When I calculated the momenta and kinetic energy always gradually loses energy as it should be, but for those who believe energy equals momentum, these experiments always produce free energy, lose it, produce it again with each swing. So again, you're saying that's what is happening. I'm just saying simplify the experiment. Make sure you know how much energy went in that first swing, and then just show that you made more momentum on the other side. I mean, obviously you're putting a lot more energy in than you think you are when you pull the weight to the outside. That doesn't work. I think I've done everything I could with this type of setup. So that's what he says. So again, this is the 4th time I've mentioned pulling it in, not pulling it out. Anyway. Yes, before Goofy tells you to keep improving the setup until you go twice as fast. Twice as fast, he's not moving the heavy side, so he's not going to be able to get the light side to go twice as fast. But anyway, until he moves the heavy side, that's the side where you make the free momentum, right? Right. Your paperclip consumes a lot of energy, by the way. So that's the part that, it could be figured out. You can figure out how many grams that is, and it's moving at a velocity, but it's like half the velocity of the pendulum because it's going up and down rather than side to side. So I don't think it could be that much momentum, frankly. I found a few more coupled pendula videos. So none of these will have unequal masses. So we'll just open one for the hell of it. I mean, this is the part that's just so silly, right? I mean, we're, a million years into this science, and they haven't bothered to do these experiments. I don't know why there are commercials on everything. Pathetic.
Coupled oscillators.
So
2 pendulums of equal length are connected by a solid.
Equal length, equal mass, blah, 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 blah. Yeah, been there, done that. Doesn't mean a goddamn thing. And obviously the momentum is conserved when they're equal masses. So, again, not interesting. It doesn't help at all. Thank you very much. So, no points. So again, just for clarity, right? I mean, if regular physics took any of this science seriously, they would have done all of these experiments. They would have already proved it takes 25 times the fuel to go 5 times as fast. But obviously, they can't prove that because it doesn't happen. All right? And in space, they would have done the 5 mass against the 10 mass, with the divergent velocities. Twice the velocity, half the velocity, and they would have had the tug of war, and they would have found out, hey, guess what? This side doesn't pull the whole experiment this way. It doesn't end up oscillating and going in a direction because this side doesn't have any more energy than this side. They would prove it so simply, right? And then they could just crash them, which has already been done, and it didn't convince anybody. You can do that with a Newton's cradle. You can take a 2 mass, okay, at one distance, and one mass at 4 distant heights, and you can crash them into each other, and it just stays right here. The explosion doesn't move this way. Okay, the explosion happens here, and you get your outcome. No evidence of this having twice the energy. So I mean, there are some experiments, but yeah, they're not enough, and it's way short. And obviously, we have some of the crash tests, right? There's no crash test video. There's no accident analysis person who will tell you, that you can do these uneven crashes and reduce the amount of momentum that comes out. That all the pieces have to account for all of the momentum. You can't destroy the momentum. You can't make your little extra kinetic energy for free. You have to use momentum to make something fly off. And momentum is conserved. And then we have the visuals where, the Mythbusters did crash a car 50 miles an hour into a steel wall. And then they crashed it 100 miles an hour into the steel wall. And the car crashed exactly twice as much. Crushed. Kind of indicating, gee, there's no sign of that 4 times, is there? No sign of it at all. But they'll just keep doing this. These are all arguments been made over and over, and they'll just keep insisting they're going to prove otherwise with some rickety, tied together, bubblegum experiment. Gluing crap on matchbook cars and shit. They're going to prove that those crash tests are false, and they're going to somehow fill the gap in the evidence record. So they don't have to ever prove that it takes 25 times the fuel to go 5 times faster, or that something going 5 times faster does 25 times the damage. 25 times. No, they're not going to ever do that, because they want to defend a fable, and it's obviously a fable. Fables have every appearance of this science. So fables look exactly like this. Unevidenced stories. And that's what this science is. 1/2 mv squared is unevidenced story. That's all it is. It's crap. Alright, that's enough of a video.